Looking at sprite sheet get. In sprite sheet get, it generates this. So we can see I have the frames of my animation displayed on the background. I have my animation running wild here attached to the mouse location. So there's some fanciness going on here, and I'm going to break it down a little bit so we can understand some of that. I think this is a better method than what I had been doing previously. What it's doing is taking each image. It's taking the image here, elf PNG, which is 12 frames of animation. So it's a single PNG file with 12 images assembled together. And we're going to go through the workflow of how to create those image sequences so that you can create animated sprites if you so choose to do so. And we will look at doing it with separate image files as well as using a sprite sheet like this. So when you have the sprite sheet, it's a single PNG file with the 12 images stacked into a grid. Now you can use tools like Photoshop to assemble this manually. Good luck. It's better to use an animation tool and then export it where it then lines everything up, because you know your animation was lined up, and then you export out the sprite sheet. Now this sprite sheet is not an optimized or packed sprite sheet where everything is put in here to make it as tight as possible. The method that we are going to look at requires our frames of our sprite to all be the same size. Each frame of this animation has the same height and the same width. So if the sprite were to extend itself and make it really, really big on some frames of the animation, really small on others, on those smaller images, there would be extra wasted pixels, but we need that additional frame size so that we're able to keep our artwork lined up during the animation cycle. So single picture. Now we're going to divide that picture into pieces. Previous method I used was loading the image, and then under each time we would call draw on it, we would copy out the information or the pixels that we wanted to see. And I was having some performance issues and decided to try and find some ways to optimize it. And I believe this is a better system, but I haven't gone through and fully speed tested it yet, but it does seem to work a little bit better. And the code is certainly nicer. So in the beginning, we need to load our image. Similar to how before, we have a pimage variable. The pimage variable then says load image. It specifies our file name. If we want to use processing.js, we need to reference that with a preload at the top of the document as well. And then what it's going to do is it's going to store each frame of that sprite sheet in a picture. Each one as a separate picture, and put those pictures into an array. That array is called frames. And what we do is for each element in the array, we tell that image, let's go get, and we say where we're trying to get from, and then how much or how many pixels we're trying to access. So that's the basic part of what we're trying to do here with that. Then when it comes time to animate, we just say draw an image on screen. We say what image, and then in this case it's now, this is what created that array of images across the top of the screen, and this is what creates the looping one where we just say, hey, draw the current sprite or the current frame number, and then we increment frame number and make it one bigger. The algorithms for doing this, for animating a sprite off of a sprite sheet, such as current sprite equals current sprite plus 1 modulus the total number of sprites, or total number of frames if you want to think of it in that term. That concept is something that you can just store the algorithm in a safe place and then reapply it in the future. If you do enough sprite animations, you will start to understand it better or memorize it. In the beginning, you store the algorithm. Math teachers around the world are going to hate me for saying this, but it's just like in math class where you say, just give me the formula, I'll plug my things in, the formula, the algorithm gives me what I need as my result. So if I want to use the quadratic equation for computing the length of the hypotenuse when I have the two legs of a triangle, you can do that. It's a basic formula. Do you have to know where that formula came from, how it all worked? No, you just memorize the algorithm, memorize the formula, plug the numbers in, and get your result. That's what we do. So math teachers, I apologize. I'm sorry. So this is what allows our sprite sheet to draw. The first part up here just draws the frames across the top of the screen. The second command draws our animation at the coordinates of the mouse. Now we're going to make a sprite. Once Flash is launched, we can just create a new document. And we really don't have to worry too much about the size of the stage or anything, because what we're going to be doing is creating a movie clip. And then from our library, we can right-click on that movie clip, and we will have an option to export that movie clip as a sprite sheet. It's built into the tool now. So if I want to create a movie clip, I can say insert new symbol. Movie clip is the default, and for this one I am going to make this my alien. So insert new symbol, and then the symbol type should be movie clip, and then we can hit OK. In our new symbol, we can see we're not at scene 1, we're inside our symbol here, we're on frame 1, and it's just going to build a basic animation. So I would encourage you to make something that's a minimum of 3 frames long, and could be certainly longer, especially if you have some animation skills under your belt and you know what you're doing. But with this, if I want to, this is going to be my alien that's going to fit in with my rocket ship, because I don't like having my little green dot. I want to have something better. So I'm going to draw my alien, but he still will be green. So you can animate whatever you want. It could just be a pulsing blob. It could be a person, a face, a bird, a plane, a train, an automobile, whatever makes you happy. So if I make my artwork, and you can make your artwork as you see fit. So there's going to be my basic alien body. If we want to add the next frame in the animation sequence, to do that, I can hit, if I wanted it to be the same artwork and then tweak it a little bit, I would hit F6. If I want to start and draw, so this is like drawing an animation flip book, drawing like a traditional flip book animation where we just have artwork on each page. Each page is a little bit different to build the animation. I will hit F7, and so that I can line up my artwork down at the very bottom of the screen is onion skinning. We can turn that on and see the faint representation of what was on screen before. And now I'm going to draw the body again, changing my feet. And then hit F7 for the next frame, and then just keep repeating until I build my animation. Record here. In the library, right-click on your symbol. Now you will notice we have a few extra options here. These are new options that they added to, I believe it was CS6 Flash. So if you do have an older version of Flash, this won't be built into it. So make your artwork and come in and use the lab if you don't have CS6 at home. There are some free utilities out there. You can find them on createjs.com. But The two that we'll be looking at here is PNG sequence and generate sprite sheet. So we're going to do both of these. And to do that, I'm first going to generate a sprite sheet. When I go to generate a sprite sheet, you will see it comes up, and now it shows me the frames of my animation, gives me a preview of what it's going to be. And we can choose our data format that we want to work with. The data format is useful because it's possible to actually import all of the information about our sprite sheet from this data file it writes if we're willing to go through the labor to write that code. Otherwise, you just read the data file that it creates and then use that as our basis. The things that we need to know is how many columns, so we can see that when we're making it, and then we'll want to know the height and width and the total number of frames or sprites. In this case, I am looking at 8. So those are things that I will need to know. And width and height is not of the whole document. I need to know width and height of my individual frames. So the data format that I prefer is JSON. And then once we've done that, it's going to save it next to where I've saved my flaw file. If you haven't saved your file yet, you might want to browse and choose where you're going to dump this out at so you can go find it later. And then you can hit the export button, and that will export your sprite sheet for you. We're going to also choose PNG sequence. I can choose where I want to put that. And for the PNG sequence, I am going to make a new project folder for that. That will be my sprite sequence. And because these are images, this will be going into a data folder. So I have a data folder. I will save my PNG sequence there. Gives me a height and width, tells me how many it's going to save. It will save with 32-bit. Then you can hit OK. And if I look under sprite sequence, I have a data folder. And I will now see that I have my individual sprites all named, where it's alien 1, alien 2, alien 3, alien 4, 5, 6, 7, 8.png. Also notice that there are 3 zeros in front of each number, so that means I could theoretically make a sprite sequence or PNG sequence that is 9,999 frames long. If you were to do that, that probably isn't a good idea. And if you were to build a file that was effectively 10,000 frames long in Flash, that wouldn't be a good idea either, because it would probably crash on you at that point. So I have my PNG sequence file folder. There's data in there, and now I'm going to, in processing, make, oh shoot, did I just do what I'm going to save my sketch sprite sequence .pde in my sprite sequence folder. Folder name, file name match. And now I'm ready to start putting in some code. The first thing that we will want to do is just make our standard basic setup stuff. So getting your basic code installed in your project. Now with this, we can prove that we have things working by making a p-image. I'm just going to call this image test. And now with that, we can go test equal to load image. And now our file name is going to be alien 0001.png. And I can say image test, and then I can load it at 100, 100. So to verify that my files are working, verify my sketch is working, that everything is saved in the right place, before we start adding in any additional layers of complexity, it's a good idea to prove that our project works. So once I've done that, I can test my sketch, and if I'm lucky, my document loads, loaded at 100, 100. It's basing that registration on the top left corner of that sprite. And here is now my alien. Now, knowing that I have 8 frames of animation, I could have image 1, image 2, image 3, image 4, image 5, image 6. I could load them all and then display them. So we can do it the hard way. So I can make all of these the hard way if I'm so inclined. And I would encourage you, as you're following along, not to do this. But I'm going to prove that it works. But don't do what I'm doing, because there is now a better way. Just requires a little repetition. So after getting my highly repetitive code, all 8 images loaded, all 8 images specified at new locations, if I view my sketch, I will see that it now draws the different frames of my animation. So it works. It's not a great way of working, but it worked. So we have a start. So it works, but it's crap and ugly, so we're going to do this a little bit differently. And with that, I'm going to let these show up, but then I'm going to change the numbers on them a little bit. All right. So I'm going to modify this so that each alien then shifts over 70. That way I can get them all on one line here. I just need to change a couple of the y values back to 100, because then I'll leave these in my sketch, and then we will show how we can also load it in a cleaner, nicer manner. So with that, what I want to do is I want to store my I can call it total frames or total sprites. I'm going to go with sprites, so it matches what we've done in previous ones. So we know that in that case, total sprites is going to be equal to 8, because we just loaded 8 images. So we know that there's 8 of these. And I want an array filled with images, because I'm going to stick these images into that array. So I'll say pimage, and we'll just call this frames. And it's an array. And we issue the command of frames is equal to new pimage, and then we have to say how many, and it's equal to the total number of sprites. We will put 8 images into this frames array. Now the next thing that we need to do is we need to put each image into the array. So this will be a much cleaner, tidier, more compact way of writing it as well as accessing it that we will see shortly. So frames, and just get some extra return so it's up higher. Frames, or no, not that. We want to say this is where a for loop is useful, because if I use a for loop, we can now cycle through this. Otherwise, we could say frames 0 is equal to, and then we could put our image into it the same way. So frame 0 is essentially equal to test 1. Frames 1 is equal to test 2, and we could do that. But that's a lot of repetitive work, and we'll be right back kind of where we are. But because these image file names, if we look at it, the image file names, it starts the same, it ends the same, and then we just have 4 sequential numbers here. That's the type of thing computers love to put together, and that's what we will do in just a second. The for loop will come to our save the day, because if we have more than 8, say you built an animation, some of you did 12, 16, 24, 30 frames worth of awesomeness. So with that, we need to come up with a better way to do that. So that is not going to be it. But what we can do is do a for loop, and we'll just do for I is equal to 0. And then as far as our lengths goes, we know then that is our total sprites. We could also do frames.length if we wanted. So while I is less than frames.length, but the length of frames is total sprites, so either of those works. Now, we can accomplish what we need to do with 1 line of code, but it's easier to read if we do it on 2. So I'm going to advocate for that. So we're going to construct our name, or the file that we're trying to load. So I'll just call it temp name, and it will be a string. And it is going to be alien. Now, some of you would think I could do alien 3 zeros, and then we can put a number in and then add in the .png afterward. But if you have, some of your frames are, if you did more than 9 frames, then you have 10, 11, 12, 13, and then you couldn't just put a bunch of zeros in, so it'd fail. But the nice thing that we have in processing, because what we're trying to get, this isn't correct code yet, but I'm going to write it out, is we want the 3 zeros plus whatever the value of I currently is. So we're trying to do that. And then we're going to add in the .png at the end. So this is the string that we're trying to construct. So we want 3 zeros plus I. There's a nice method that is built into processing where we can specify through number format, and I've pulled it up in the help file here, and it's NF. And the way that NF works is we say then the base number we're starting with, and then how many digits long we want it to be. So in their example, A was 200. They said they want it to be 10 digits long. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it adds however many zeros you need to make it 10 digits long, or 10 numbers long. So if we say 5, it makes it 5. If you say 3, it makes it 3. So in our case, we want it to be 4, because when we look at sprite sequence, we will see that it is 4 numbers, 1, 2, 3, 4, that we're trying to create. So with that, all we have to say is NF, number format, and then the number we're trying to format, I, and then we change it to 4. So that will now generate something, except that it's not going to quite line up yet, because the first time through this for loop, I is equal to 0. So what I'm going to do is print out. So I will use, this is just so we can see what it is. So we'll just print out temp name each time we go through this. And it should be alien0000.png the first time, and then 0001, 0002, and we'll verify that it works. So if I run my sketch, we'll see it printed out 0, started at 0 and went through 7. But the image sequence exported out of Flash didn't start at 0, it started at 1. The nice part about a for loop is you can determine what is your starting value. I don't have to start at 0, I can start at 1. And then we can go all the way up to where I is less than or equal to the total number of sprites. And if I run this again, I will see that this time through, it generated 1, 2, 3, 4, 5, 6, 7, 8. So it's now generating a string of the name that we are looking for, because that corresponds to those files. So if we compare, and just get rid of that we don't need. If we compare here, and we don't even need this because that's not doing anything. So out of actual usable lines of code, these 1, 2, 3, 4, 5 lines of code perform the same operation as 15 lines of code, or 14 if we count the 8 here plus our 8 variables. So this is going to be a much better way. This made the name, but now we have to actually populate our frames array with those images by saying load image, and we can do that. But if we have 50 frames in our animation, this is a much better system. If we have 1 frame in our animation, just use load image. If we have 3 frames, this is going to be easier down the road. But if you have 3 frames, big whoop. I mean, so you have, depending on what you do, you always look at what is either going to be easiest now or easiest and most flexible down the road. And you kind of decide what strategy to follow. So here now, that generates the name. Now all we have to do is say frames. We have to specify which one. And we start out by specifying position 0, and now that's going to be equal to load image. And what we're loading is temp name. So that's now going to load into my array. So as was kindly pointed out, my mistake, I wrote 0. It's supposed to be -1. It doesn't work yet. If I run this, what I'm hoping I won't get is an error message. And I got no error message, so that's a good sign. What we need to do to see anything show up on screen is we then need to say, inside our draw loop, say image, and then frames, and we have to say what frame number we want to see, and that's our image, and then we specify where we want to see it, and I'm just going to put it equal to the mouse X and the mouse Y. Now I did not put a number in yet because we have to figure out what number to see. If I wanted to just randomly grab 5, we'll do that, and if I run it, we should now see frame 5 attached to the mouse. Now our background isn't updating, so we're stuck, watching it fill the screen, and that looks kind of fun. It works with a hard-coded number, but I want a number that changes. So what we need to do is we need to have a variable. It will be an integer, and it will be current sprite or current frame. You can go with whatever naming scheme you want. Current sprite will start out equal to 0. And now we will specify when we grab and show it, we will show current sprite as our frame, which is the very first frame in the sequence. Now, knowing that, all we have to do is make the sprite update itself. And this is an algorithm that is a one-line algorithm that works really, really well. You say current sprite is equal to parenthesis current sprite plus 1. And then we do a little bit of math here. We use the modulus, and then we divide it by our total number of sprites. This is now using our math that returns the remainder value. So current sprite is 0 equals current sprite plus 1, that's 1. 1 divided by total sprites, that's 8. 1 divided by 8 is 0.125. 0.125 is not a whole number remainder, so, or it's not, the remainder is in 0.125, but when we divide it, 0 remainder 1. Sorry, I'm used to always wanting to use decimals. And then we repeat, and then it's 0 remainder 2, 0 remainder 3, 0 remainder 4, on until we get up to 7. Then we will reset. It'll be a remainder of 0, and then it keeps looping. So it gives me a value of 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. That's what this one line of code will do. You could use a current sprite plus plus. If current sprite is greater than total sprites, reset it back to 0. So you could write it out using an if statement. It's about 5 lines of code. This one line, I think, is better. Now, doing that means every frame current sprite is updating, and now we should see my little alien dude is updating. And I'm going to just put in a background command. So the background updates itself, so it's clean. Run it. Now we can see it looks like he's swimming and he's attached because he registers to my X and Y. There, if I wanted him centered on the mouse, I would offset his position, so I could offset off of the mouse X by half of his width, which is approximately 35, and half of the Y, I think it was about 18 or 20. We'll just do 20. So you can offset those a little bit, and then you'll see that he's closer to centered on the mouse. Got my little alien swimming dude ready to fly across and run into my rocket ship.